file. Okay.
All right. Let's take a look at the homework. Now, regarding the quizzes, there's a couple of people still to get it made up. So we may wait a while, even after those people get it made up. We may wait a while to go over them. So I'll let you know when everybody's got it made up. If you really want to come in and see what you missed or see those things, you can come do that. The scores were good. The scores are traditionally pretty good on this quiz. I told the other class I don't mean to rain on your parade if you felt really great about your good score. You should. I mean, you should feel good. But we did spend extra time. I think the things on that quiz are so fundamental and so important, the connections between F and F prime, F double prime, and all that stuff with the chart that we need and have to use all year long that are so key that we spend a little extra time there. And then if you do have those connections figured out, there were a lot of problems on there that went fairly smoothly for you. So that's key. And so I guess I tell you that I think the class average was out of 44 points, I think it was about 39 out of 44. I mean, so that's pretty good. And better than most quizzes we do. So I guess what I say to you is if you didn't score well, then, and these are very fundamental ideas, you probably should be getting in and figuring out where you're going wrong with that stuff, because it's going to haunt you on many quizzes probably down the line. And also, if you did do well, there's a tendency sometimes, and I don't know if this fits anybody in here, but there's a tendency sometimes to let down and say, oh, good, now I'm back on track, I got this, and I don't need to maybe work as hard as I thought maybe I needed to. And I'm not sure that's true. So I guess you don't want to get a false sense of security that, hey, I got this, no problem. But anyway, that's my comment about the quiz. So for the most part, good job, and I think we get those connections. But even with that said, there are some fundamental basic concepts that I'm still not sure we're totally on the right page with. Because I've talked with a number of people just today, started with some this morning, that had some questions that were like, wow, I mean, you're a lot of times overthinking it. You're making it way too hard, and you're not grasping a fundamental idea. So I want to start with this right here. If I give you a function, now let's say I give it to you as an equation or a graph. What would be the graph of that? It'd be a parabola, right? So let's say I give you either the equation or I give you this parabola, whatever it is, and I ask you to find that, either as an equals or as an estimate. Because in the homework today, there were a number of problems that said estimate F prime. Estimate F prime. And then there were some that said find it exactly. Now, to be honest, until yesterday, or until Friday, we didn't even really have a way to find the slope exactly, did we? Almost everything we had at that point were estimates. So I would like to just stop for a second here and think back to all the different ways we have talked about finding F prime and -1. If I give you this kind of picture or this equation, give me one way to find or estimate F prime and -1. Okay, the very first day of class, right? That's what we talked about. Pick 2 points really close together. Since you have an equation, you would plug them into there, right? So that was question 1 on today's homework. You had a table of values. Pick 2 points in the table that are really close together and do a slope calculation, right? Just do a simple y minus y, x minus x. Okay, that's one way. What's another one? And do what with it? You leave that. Go ahead. Okay. So when we say tangent line, we mean you're talking about where we come in here and sketch this and kind of do a rise over run thing, that kind of thing? Absolutely. Right? Now, I like how she said tangent line, because there was a problem today where it talked about the 0.3 and the 0.5, and there's a line between those, and that's average rate of change. And then it asks for the slope at 3 and the slope at 5. I guess the first thing I should have started with is when you see f prime and -1, what do you think? Slope, but let's be more specific than that. Yeah, I usually let you get away with that, don't I? Let you say slope or rate of change, but let's be more specific. It's the slope of this graph. It's the slope of the tangent line. If we were really going to be technically correct every time we said it, we wouldn't just say the slope of the curve at -1, because curve really doesn't have slope. I mean, it does, but by definition, the slope of the curve is the slope of the line tangent to the curve at that point. So when we do the slope at -1 on this parabola, we're really doing the slope of that tangent line. Okay? So again, these are some technicalities, but we're getting far enough into it now, we've got to start paying attention to the technicalities. They are important. Okay? And then, of course, what did we learn yesterday? Another way to find the f prime and -1. The definition, right? The technical definition of the derivative, which is this guy right up here. Okay? So again, it's just important to understand that. So sometimes I think people on the homework are trying to do this long definition thing when all you really needed to do is slope between 2 points. Okay? And so we don't want to make things harder than they are. And we want to understand the basic concept. All right. So what I'd like to do, let's kind of go in order here. Let's review this definition. So where this came from, Riley was gone, Brittany was gone, who else was gone Friday? Richard was gone Friday, right? It seemed like we had a number of people. So what we did is we looked at this particular thing right here, and we said that, okay, we plotted 2 points. So Riley, where this crazy thing comes from, this weird looking thing right here, it just came simply from this. We said we want to find the slope at point A, which means we want this tangent line. We want the slope of this tangent line. Okay, well, let's pick 2 points. Let's use one as point A and use one as A plus H, a point to the right. Okay, we don't have to pick a point on both sides, right? We talked about that on Friday. We can pick A as one of our points and then a second point to the right of it. And what we want to do is let this point get really close. Well, if this point gets really close, what happens to H? Gets smaller and smaller. So as this point gets closer and closer to this point, H is getting smaller. What we say is H is going towards 0. So as the green point gets close to the blue point, we have H getting close to 0. And we want them to get closer and closer. And then we just do a slope calculation. So we do f of A plus H minus f of A. And that's the top over here. And then we do the bottom is we subtract the x's. So A plus H minus A. And so that's just H. And so that's all this is. So if we look at this formula, what we said on Friday then is this part is what? This part right here. What is this right here? That's just slope between 2 points. Are they 2 close points? Okay, let me say that again. Everybody hear that now? Are they 2 close points? They can be, depends on what? Depends what H is, right? So this is simply slope between 2 points. Are they close points? Maybe. If H is 0.0001, you had some homework questions like that, right? They said let H be 0.001. Well, if H is 0.001, then this is just slope between 2 pretty close points. But it's still slope between 2 points. It's still average rate of change. Okay? So then what does this part do? Limit as H goes to 0. It makes the 2 points become 1. In other words, we now get instantaneous rate of change. We get the tangent line. Okay? And so that's the key element of this. This part, it's called the difference quotient, right? It's just, you subtract y, subtract x, it's different, and then divide it, so it's a difference quotient. This thing here is just slope between 2 points, algebra 1. This is the key that makes it calculus. This is what gives us the slope of 1 as H gets close to 0. then we said there's another version that we could do if we just kind of switched it. If we made the first point A and the second point X, and we let X get close to A. So as X gets close to A, then we subtract, you know. So that one doesn't show up very often, but we have it there just because every once in a while it does. It's basically the same thing. So again, this part and that part. Okay, all right, so that's the thing we learned. Basically what that was, it's not, as a concept, it's not even new. I mean, we said that the first day. Let's get two really close points. Let it get closer and closer and closer. And that's all that's doing, just in math notation. That's it. Okay. All right, next thing. I want to look at your homework question number 34. Okay? Now, number 34 said, limit as delta x approaches 0, square root 9 plus delta x. We didn't really talk about this, did we? I think I might have mentioned it to a couple people that asked about it. Okay? They gave you that right there, right? Okay? Now, before we go into that, I might make a comment here about number 43. All right, here's number 43. Now, I'm not going to go through this in great detail today. We'll look at number 44 in a minute, okay? But, all right, let's just, some people that came in this morning, we kind of went through this. So, if f of x is x cubed, this was number 43, okay? And we want to find f prime of 4, all right? So we come over here, we use this thing, okay, so A is a 4, right? So we're finding f prime of 4. So that means we're putting a 4 right there for A, which means we're going to put a 4 right there, we're going to put a 4 right there, right? And so that's where this comes from right here. Okay? So f of 4 plus h minus f of 4 over. All right. And then we went through this thing, well, what's f of 4 plus h mean? What's f of 4 plus h mean? Yeah, 4 plus h is what you plug in place of x. Right? Remember the German short hair thing? Right? Let me see if I can find that. Right here. If f of x is 3x squared minus x, then f of a is 3a squared minus a, and f of t is 3t squared minus t, and f of 2 is 3 times 2 squared. You just put those back. And if it's f of German short hair, we put a German short hair in for x, right? 3 German short hair squared minus German short hair, right? And if it's 7 plus h, if it's f of 7 plus h, we put a 7 plus h in for x there, and we put a 7 plus h in for x there, right? I mean, that's what that means. Okay? All right. So, f of 4 plus h means take 4 plus h and put it right there for x. So we get 4 plus h cubed minus f of 4. So we put a 4 in for x, and we get that. Then we FOIL this out. Now, here's all the algebra that you have to do for 4 plus h cubed. This is the part that threw most people, was the algebra. 4 plus h cubed means 4 plus h, 4 plus h, 4 plus h. So you do the first two, FOIL them. Then you got to take 4 times everything. Then you got to take h times everything. And you get all this. And then you combine your like terms. Okay? It's like a ghost coming back to haunt me. What's up, Mr. Reed? How you doing?
Good.
You got the whole week off or what?
Yeah, I got the whole week off.
Taking calculus this year?
Yeah, it's easy because it's the same as.
Same thing we do.
Yeah, it's the same.
Where are you
stuff.
at? Down here, or you? Where are you?
I was maybe.
Iowa State.
Yeah.
Taking Calc 1.
I got Calc 2 next semester. That's supposed to be the hardest class though.
Calc 2's hard. Calc 2's hard. I don't know. Calc 1. I don't know. In college, I almost thought Calc 2 was about as hard, but Calc 1 was about as hard. But I think that's because when I first took it, I wasn't really ready. You know what I mean? And I think I kind of spaced. I mean, I guess I wasn't ready to study that hard. Maybe that
Me too, but
Yeah.
because I know it all.
So you haven't had to study because you had it last week.
Yeah.
All right. Awesome.
Yeah.
Thanks for stopping by.
Yeah.
Take care. All right. So, all right. I always forgot Thanksgiving week. A lot of times college kids start coming back. That's good. Anybody have any brothers or sisters coming back this week? Okay. Tell them to stop by if they're coming back tomorrow. I Well, we had school Wednesday. Last year we had school on Wednesday, so a bunch of people came back. A bunch of people. All right. So anyway, when we FOIL this all out, we get this H stuff, and then minus 4 cubed, minus 64. Okay? And so those cancel out. So that's nice. And then we can factor out an H, and of course that was the whole key step, right? Because we want H to get close to 0. Matter of fact, we'd like to plug a 0 in for H, right? Well, we can't plug a 0 in for H when we have H in the bottom. It'll divide by 0, so that's no good. But right here, we can factor out an H and then cancel it, and then we get down to here. And so then we can put a 0 in for H, and sure enough, we get 48. Now, we got to remember, what does that 48 mean? Of what? Of what function? At 4, but what function? Right? Come on down. See, I mean, it's so easy to get lost all the algebra, we forget what we were doing. We were finding f prime of 4. We were finding the derivative of x cubed at 4. Well, if you look at x cubed, it would be like this. Out here at 4 would be way up here. It would be going almost straight up. So does it make sense the slope's 48? Kind of makes sense. Okay? Kind of makes sense. But you got to understand when you get down here what you're doing. And this whole thing with plugging a 0 in for h, we do that because we want the 2 points to become 1. Which means we want h to get closer and closer to 0. And if we can actually plug in a 0, that's great. But that doesn't happen until we get that. Okay, now, back to number 34. What you were supposed to do in number 34, it says that is the limit definition of a derivative for some function f and some a value. So what they're doing there, let me do it in red here, is they're starting you here and wanting you to get back and tell them what must have started with. Well, here's what I would do. Right away I would look at the 4 plus h. Now what did we just get done saying? We said f of 4 plus h means you take 4 plus h and plug it in where x is. So, pretend we hadn't started here. Pretend we'd started here. I would have looked at this and saw the 4 plus h and said, hey, that must be where the x was. So this function must have been what? X cubed. The 4 plus h is where the x was. So this function must have been x cubed, and this 4 is where the x was. So this function must have been x cubed. And we must have been doing what a value? We must have been doing the slope where? At 4, because we do the slope at this point, and that's the a in the a plus h. So now we look at number 34. And number 34 says, okay, first of all, the delta x is the same as what? The h. So my function must have been, well, I see the 9 plus h sitting there. That must be where the x must have been. So this function must have been what? This function must have been square root of x. And I must have been doing the slope at what a value? 9. Because that's the a plus h. That's the a in the a plus h is the 9. So this limit right here must be the setup for doing the derivative of square root of x at 9. That's the part I was hoping you could at least do. The other part where they wanted you to use your calculator and do a graph, and we're going to talk more about that tomorrow, so we'll just leave that for right now. Okay? So this limit, now it would have been easier if they, instead of putting a 3, they would have put square root of 9, right? Because we usually do f of a plus h minus f of a. So this must have been f of 9. Well, f of 9 would be square root of 9. Of course, square root of 9 is 3. So that's where the 3 came from. Okay? So it would have been easier if they would have had that. All right. Now, here's something that you're probably going to need to review before our next quiz. Everybody in here should know what the square root of x graph looks like. Can somebody tell me real quick? It says sideways, top half of the sideways problem. You got to know that. You got to know that. So if tomorrow we work this out here at 9, I would expect a pretty small number, pretty flat slope. I'd expect a positive, maybe a half or a third or a fourth or something like that. I would expect a fairly small number. Okay? Now, 35 said what? Said the limit as h went to 0, cosine h minus 1 all over h, right? Now, I look at my definition of the derivative, and I'm looking for an a plus h. I don't see one. I just see an h. That's confusing. I'll bet it was this. I'll bet it's cosine of 0 plus h. And instead of 1, it sure be nicer if it said what? Cosine of 0. Isn't that 1? Yeah. See, if I wrote it that way, now it would look a lot better. So on this one, what is my function? What must my function have been? Cosine of x. The 0 plus h is plugged in where the x was. So the x was right there. So cosine of x. And we're doing the slope at 0. Now think of the cosine graph and think of the slope at 0. What would it be? No. Cosine graph has a peak at 0, right? So wouldn't its slope be 0? So we would expect, if we worked out this limit, we would expect to get 0 for an answer, and we'll do that tomorrow. But I wanted you to focus on being able to recognize, kind of in reverse, recognize a limit problem that was set up in that format. Okay? All right, let's take a look at number 44. All right, there are 3 algebra techniques you need to be able to do for, just for these type of problems that you might have on our next quiz. The first algebra technique, so I don't, maybe somewhere separate in your notes or something you might, or somewhere you might make a note of this. I don't know if it has to be separate, but we have to be able to do the factor and cancel thing. Okay, which we just already got done doing. You know, the FOIL, expanding out FOIL, doing that kind of stuff. Okay, we got to be able to do that. The second thing we have to be able to do, and this came into play on number 44, is we have to be able to get a common denominator. Now, Mrs. Payne likes to call this the bow tie method. Have you heard of that? Okay, the bow tie method. Now, the beauty of the bow tie method, well, let me erase that. Let me change that. Let's make that 1/6. The thing about the bow tie method is it does not give you a least common denominator, but we don't care. I don't care if we get a least common denominator. I just want to get a common denominator. So right here, the least common denominator would be 6, right? So you wouldn't have to mess with this one. The bow tie method, though, says do what? It says you take this times this, which is 18, and then you take the 6 here times the 2. That's a terrible looking bow tie. And that's 12. And you take the 3 times the 1, and that's 3. And then you add or subtract them, whatever the problem says. And then you get this, and then you have to reduce it. Right? So the only problem with the bow tie method is at the end you'd have to reduce it. And I guess it looks like a bow tie or something. So it's a bow tie, right? So what you do is to get a common denominator, you simply multiply the bottoms, and that's your bottom, and then you take this bottom times that and put it on top, take this bottom times that and put it on top, and then you add them or subtract them, whatever the case may be. Okay, we need to be able to do that. So on this particular problem here, number 44, we were told that f of x is what? 2 over x, and we're supposed to find f prime of 4. So the first thing I should write down on one of these problems is, nope, there you go, limit as h approaches 0. Okay, for you guys who were gone, the directions say use the limit definition, which is this guy right here, to do f prime of 4. So that means I'm going to take a 4 and plug it right there where the a is. So that's what. Okay, so read the rest of it to me. So right now I'm just putting the 4 where the a was. Whoops. Minus f of 4 all over h. Okay, and here's where the German shorthand thing comes in. So f of 4 plus h means Right, put a 4 plus h in for x, right? So I would get limit, as h goes to 0, 2 over 4 plus h minus. Now, I actually like putting 2 over 4 here. You can put 1/2, that's fine. There are times in some of these problems where not simplifying them actually works out better than simplifying them. So it doesn't matter. If you put 1/2 there, that's fine. And then all over h, right? And so now, so my next step, limit. So now what I have to do is just do my algebra. So on yesterday's, the algebra was we had to FOIL out, factor, cancel, things happen. Okay? Here we have to be able to get a common denominator. So here's where the bow tie comes in. So I'm going to have h down here. I'm going to have, what's my common denominator going to be? Now again, I probably would not distribute those, but you could. It wouldn't matter. It turns out in this problem it won't matter. But my common denominator is going to be the 4 plus h times the 4, right? Just like we did a minute ago. The 6 times the 3 was 18. Okay, so that's my denominator. And now I bow tie. So this, now here's how I usually write it, to be honest. I can't get out of this habit because I didn't learn the bow tie method when I was young. But I'm going to take 4 times that 2, right? That's going to give me 8. Minus, and then here, the way I did it is I'm going to multiply the top and bottom by 4 plus h. That's really what I'm doing, right? So I got that. So I got to take the 4 plus h times the 2, which would be what? Now here I should distribute it out. Now here's where we got to be careful though. 8 plus 2h, but I'm subtracting it. So either put it in parentheses or minus 8 minus 2h. Make sure you do that. Now again, I already, handful of people in the other class already screwed this up on one of their homework problems today, of distributing that negative through them. Okay? You got to make sure and do that. Okay? Because our formula has a minus in it. Our formula has a minus in it, and it's going to cause us issues. Okay? If we don't get used to doing it. All right, now we got this messy thing where we have a fraction divided by something else. So now let's review that. If I have 2/3 divided by 7, that's like saying 2/3 divided by 7. Well, what do you do if you're dividing by 7? You flip and multiply. Invert the 7 and multiply. So what are we going to invert here? We're going to invert the h. So I'm going to move that h, and I'm going to invert it and put it up here. Okay? So I'm dividing by h, so I'm going to invert and multiply. Now, what nice things happen up here? Well, 8's cancel. And let's change colors here. That leaves me with just a negative 2h. Won't the h's now cancel? And that, if you remember, yesterday was the really key thing, was right here when these h's canceled. That's what allowed me to put a 0 in for h. So, right here, when these h's cancel, I better rewrite it here. I got negative 2 over 4 times 4 plus h. Limit as h goes to 0. So the h dropped out. That allowed me to cancel my h's. And now I can put a 0 in for h. So that gives me what? If I put a 0 in for h. Negative 2/16, or, again, since we bow tied, we may have to reduce when we get to the end. Negative 1/8. Now, let's not get lost in the weeds here. What did we just find? Of this graph. Now, by the time of our next quiz, you better be able to tell me about what that graph looks like. Now forget the 2 for a minute. Pretend it's 1 over x. The 2 is just going to be a vertical stretch. What's a graph of 1 over x? It's that kind of slanted or tilted hyperbola kind of thing. That's the graph 2 over x right there. It's a stretch of the 1 over x, but essentially looks the same. And out at 4, we'd be out here somewhere. Does it look like the slope would be negative 1/8 out there? Seems reasonable. Seems reasonable. Okay? So there we go. That's what we will call, after today especially, we will call the long way of finding the slope at 4. by using the definition of the derivative. But it's an important one. We're going to learn a shortcut today. Some of you already got an idea about that shortcut. But it's important we understand where it comes from. It comes from the fact that slope between 2 points as the 2 points get closer and closer and closer together. Okay, so I think I want to just go right into that. So let's do it. Let's figure out, let's learn our shortcut. So I want to take our picture from yesterday. If you've got questions on some other problems, you may need to come see me. We may have some time tomorrow. We just need to take a look at some other stuff here today because these take a little bit of time. All right, so here's what I'm going to do. By using this definition, f prime of a, if I want to find the slope at 4, we go through that whole big mess we just did. Then what if I wanted to know the slope at 2? Do it all over again. Slope at 3, do it all over again. Slope at 1, do it all over again. Well, heck with that. How about instead of doing the slope at a specific point A, we do it at all points X? Would that make sense? And then if we had, then we'd have a formula, an expression for f prime that we could then just plug those numbers into. That would seem to make sense. So all we have to do is tweak our picture a little bit. Instead of call this point A, we'll call it point X. And we'll call this X plus H. And that would make this f of X, and that would make this f of X plus H. And so our formula, if we make that small little tweak, would be f prime of X would equal the limit as H approaches 0. You tell me. I'm just doing this, but with X instead of A. F of X plus H minus f of X all over H. From this day forward, when we talk about the definition of the derivative, we'll use that one instead of the A one. Because this one works the same. If we want to find the derivative at 2, we'll do this one, then we'll put a 2 in at the end. Or we can put a 2 in at the beginning, whatever, depending on how we're supposed to do it. Okay? So most of the time we talk about definition of derivative, this is the version we talk about. This finds its f prime of X. All X's, not just f prime of A. Now, I would suggest that we already have a few expressions that we know for f prime of X. For example, you don't write this down yet, but if f of X equals sine X, what's f prime of X? Remember when we did that? It's cosine of X. And if f of X is equal to e to the X, f prime of X is also e to the X, remember? It's its own derivative. And I would even venture a guess that we know a couple more. If f of X is 2x, what's the slope at all x's? Isn't it? It's a line. And I would even guess we know one more. If f of X equals 7, what's f prime of X? 7 is a horizontal line, and its slope is always 0. So I would say we already know some rule. Now, I get tired of writing f and f prime and f and f prime and f and f prime all the time. So I'm going to show you a little shortcut notation I'm going to use the rest of the day. And it goes back to this d dx, dy dx notation that I've shown you before. Here's how I'm going to write that first one. This says the same thing, but it's a little shorter. Not a lot shorter, but a little shorter. What that says is the derivative of sine x is cosine. Okay, so I can do it just on one line. Now, between the rest of Chapter 2 and into Chapter 3, we're going to have a page full of these kind of formulas that we will have to know. Okay? So we got that to look for. All right. But, anyway, those are some that we already know. All right? We just figured them out from slope, and we did it by plotting some points and so forth, so on. All right. So here's the one I want to work out with you right now. I want to do the derivative of x squared. Okay? So, f of x is x squared. I want to do f prime of x. by our definition up there on the board. So I'm going to write it out to start. You guys might want to write this with me, because you're going to have some similar ones to do today. Limit f of x plus h minus f of x all over h, right? Oh, I never told you that third algebra thing either. I'll tell you that here in a second. Right? So that's my first step. Remember, I don't have a number to plug in for the x, like the 4 we did on yesterday. What about this? F of x plus h. What's that mean? What's that mean? Take x plus h and plug it in for the x. So this is going to be x plus h squared minus f of x. X squared. Yeah, put an x in for x. X squared. All over h. And what? Foil that out. What do you get if you foil that out? X squared. Would it be 2hx or 2xh? Because you'd have an xh plus an xh, right? So 2xh plus h squared and minus the x squared. Correct? Okay, what happens there? That's nice. The x squareds will zero out. I think we can now, right? I think now that those x squareds disappeared, we can factor out an h, right? And doesn't that sound familiar? Right? We got 2x plus h all over h. And now won't those h's cancel? So we got limit as h goes to 0, 2x plus h. Now what? Wasn't that the whole point of canceling out those h's, right? So 0 could go in for h, and we get what? You expect that? Some of you guys had already been talking about how when we start with a function f that's squared, the derivative is going to have one less power, right? Okay, you notice how we were doing the graph, the matching cards and stuff. Okay, some of you had mentioned that already. So we just added one to our list. We just added one to our list right there. The derivative of x squared is 2x. Now, if we wanted the derivative at 3, what's the derivative at 3? 6. Derivative at 4? 8. Derivative 5, right? And that's so much faster. So we did the derivative for all x's, got ourselves an equation for f prime of x from the original f equation. All right. I'll let you do most of this one. We're going to do x cubed. Now, we already did x cubed for f prime of 4 on today's homework. That was number 43. This time you're going to do f prime of x. That was the one we got 48 for, remember? So limit as h goes to 0. I always like writing the f notation. Now, I know you don't have to always. Maybe you got it on your paper. Maybe, oops, that's an x. Okay. I always like to write the f notation out so it reminds me what I'm doing here. So f of x plus h. So what's this going to look like? So that's going to be x plus h cubed all over h. Now you got to FOIL that out, don't you? Have fun. Okay? Give you guys a few minutes to finish that. A little algebra practice. All right. Now, my guess is, I mean, there's just a lot of algebra here, right? And so some of you are going to need more practice on that algebra, some less, but, okay? Now, let me just remind you, did Mrs. Payne ever show you the Pascal's triangle? I'm not sure if Mrs. Clark or Mr. Cool, did they ever do Pascal's triangle? Okay. Pascal's triangle, I'm just a little side note here. You don't have to be able to do that. But down in the corner here, I've got Pascal's triangle. 1, 1, 1, 1, 2, 1. Remember that? Yeah. If you've seen it, where you take like the 1 and the 3 makes the 4, 3 and 3 makes the 6. And that's how you make each new row. Pascal's triangle has all kinds of cool little mathematical uses. Okay? One of them is binomial expansion. If I had x plus h to the 0 power, of course that's just 1, top row. If I had x plus h to the first power, that's 1x plus 1h, 1 and 1. X plus h squared would be 1x squared plus 2xh plus 1h squared. The coefficients are those numbers are the coefficients on the binomial expansion. So when I get down to x plus h cubed, there's a little shortcut in doing this. Now you'd also have to know that when this expands, I'd have an x cubed term, I'd have an x squared h term, I'd have an xh squared term, and I'd have an h cubed term. I'd have one of all of those. And then Pascal's triangle tells me that there'll be a 1 on that one, a 3 on that one, a 3 on that one, and a 1 on that one. Kind of cool. So when that expands, it would be that. Now it can come in pretty handy if you had an x plus h to the 7th, for example. Right? Instead of foiling that all out all those multiple times, Pascal's triangle could be quite a help on doing that. We're not going to do anything beyond the 3rd power, so don't worry about that. Okay, so if we go back to this, okay, so when I expand this out, I end up with that. Of course, like we said, the x cubes are going to cancel. Once the x cubes zero out, what do you notice up top? You can factor out an h. So if I factor out an h out of each of those, it looks like this. And of course, the key step again is because the h is canceled. And when the h is canceled, when I factor out that h, that allows what? To plug a 0 in for h. When I plug a 0 in for h, that's going to go to 0 and that's going to go to 0. And so my answer is? Yes. So if I have f of x is x cubed, the derivative is 3x squared. Don't say anything now. Some of you are seeing it, I know. Maybe all of you. Derivative is x cubed, or the derivative of x cubed is 3x squared. Let's go over to a new page. Let's write that down. So, we just figured out that the derivative, let's add that to our list. The derivative of x cubed is 3x squared. So if I was really mean, I would now make you do x to the fourth, but you know it's going to be 4x cubed. You see the pattern, and that's exactly what it's going to be. And so we have and I just, to me, that is so cool that kind of easy pattern comes out of all this mess. And it's really just slope. It really just comes out of a slope equation. And that works. And that has a name, that's called the power rule. And so what we're going to say is when you have x to any power n, when you have x raised to any power n and you want to do its derivative, the derivative is what? N x to the, you subtract 1 from the power. So what do? You bring the power down in front as a multiplier. So you bring the power down in front as a multiplier and you decrease the power by 1. That's called the power rule for derivative. Now, for us, we'll call that the shortcut, right? That's the shortcut. So we got the long way by the definition of the derivative, and we got the shortcut. But the shortcuts are all going to come from the long way, right? We wouldn't have known about the shortcut unless we went through and done it the long way. And all of our shortcuts will come that way. Even sine x, the derivative is cosine x, we can do the long way to show why it is cosine, rather than what we did, which was plot a bunch of points and kind of guess that it was cosine. All right, let's do some examples. So on your homework, there's 2 problems I'm going to have you do the long way. And you're going to have to practice those algebra things I was telling you. I still haven't told you about the third algebra thing, but I'll tell you about that in a second. 2 that you're going to do the long way. All the ones in the book, if they ask you to do f prime, they say things like find a formula for f prime, find an expression for f prime. What they're saying is like 4x cubed, that's an expression, that's a formula for f prime. So they're saying do the shortcut, write it out. Write out your answer. Okay? So let's just take a look at a couple of examples here. So what if I had 5x cubed? Now the formula doesn't say what to do with that 5. Yeah, doesn't it make sense that you bring the 3 down in front and then make 15? It would seem to make sense. Let's think about it a minute. What does 5 do to the x cubed graph? Okay, remember we're going to get into some shift and stretch questions here now. It's going to stretch it vertically by 5. Well, what's that do to the slope? Should it multiply it by 5? I mean, think about it. If your y values are going over 1 and up 2, and now you made your y values all 5 times as much, if you go over 1, you're now going up 10. So it would make sense that the slope would also multiply by a factor of 5. So it does make sense that this would be 15x squared. So there's one rule. That if you got a number set out in front, when you bring your power down, you just leave that number there, you multiply by it, everything works out fine. It makes sense because of that whole thing we learned about stretching. All right. What if you had this? Now, one thing you could do is FOIL that out. Okay, you always have the option to simplify things if you can first before you do your derivative. Matter of fact, some of your homework problems at the end, you have to do that first. You have to simplify. We'll do an example up here in a minute. But I would suggest not FOILing this out. Well, okay. Yes. Okay, let me make this one a little more difficult, where you wouldn't even think about FOILing it out. Let me change that second power. To the 20. Okay, let's change this to x minus 3 to the 25th power. Okay. Now, what is that x minus 3? What's that minus 3 do? Right, 3. Does it change the slopes? Doesn't change the slopes, but doesn't it change where they are? I mean, on your graph, if you had a slope of 1 here, and you shifted 3 to the right, now that slope is shifted 3 to the right. So does it make sense that the shift will still be there in your derivative? Absolutely. So what are you supposed to do with the 25? We'll bring it down in front of those parentheses, and then this will be to the 24th power. Just like that, absolutely. So if you have a shift in parentheses, just keep the shift and just bring the power down in front, decrease it. Works out fine. Okay? Now, let's do that one that we just had up here. Ryan said it was 2x minus 6. Let's actually do that two different ways. Let's write it the way I first wrote it, which was x minus 3 squared. Okay? Let's first do that. Okay? And let's do it with the rule we just talked about. So we bring the 2 down in front, right? Have x minus 3 to the first. Which, of course, we can tell is going to be 2x minus 6 if we want to go ahead and distribute. It wouldn't have to, but we could. Okay? All right, now let's pretend that we had decided to FOIL that out first. Okay? What would it be if you FOILed that? Minus 6x plus 9. Now, shouldn't those two have the same derivative? Shouldn't this one and this one have the same derivative? They're the same graph, right? They're just two ways of writing the same graph. So they should have the same exact derivative. Well, there is a rule that says if you have multiple terms added together with powers, you can do the derivative of each individual term. So, what's the derivative of x squared? 2x. Minus, what's the derivative of 6x? We got to think about that. Oh, wait, 6x, that's just a line. Its slope has to be 6. But let's think of the power rule. You would bring a 1 down in front, and then this would be x to the 0, which is 1. So it would just be a 6. Okay, so that makes sense. Plus, what's the derivative of 9? Well, that's a constant horizontal line. It's got to have a slope of 0. Let's think about the power rule. Wouldn't another way to write 9 be 9x to the 0? Wouldn't it? Bring a 0 down in front. Of course, that's going to wipe out everything. Bring a 0 down in front. That's going to make it 0. Right? So we don't even need it. So, sure enough, we get the same thing. We get the same thing. Okay? Let's go to a new page. Let's go to a new page. Voice control. Let's go to a new page. Let's go to a new page. See, I just had to talk loud. Okay, so. All right, so let's do this one. Okay? This is one on your homework you're going to do the long way. This is where you're going to need common denominator. Okay? But let's do it the short way first. Isn't this a power? Isn't this a power? It's x to the -1. So many times we have to take problems and write them as a power first before we can use the power rule. So what will the answer be? -1. We have to subtract 1 from the power. So if the power is -1, you subtract 1, it's now -2. So it works for those. Okay? Let's do this one. Now, this one is one you're going to need the third algebra technique when you do this the long way, because you're going to do this one the long way also on today's homework. Square root of x. But isn't square root of x a power? It's x to the 1/2. So what will that? 1/2 x -1/2. Yes, you were going to have to do fractions without a calculator. So we take 1/2 as a power and we subtract 1, which would be 2/2. So 1/2 take away 2/2 would be -1/2. That would be it. Okay? Now, in a minute there, I'll show you the algebra technique you'll need to use when you do that one the long way, because those two right there, I'm going to have you do the long way as part of your homework. Okay? Let me give you one more with fractions. Cube root of x squared. cube root of x squared. That's the same as what? X to the 2/3. The root is the denominator. So what's the derivative of that? 2/3. 2/3 x to the negative 1/3, because you take 2/3, subtract 3/3. That's negative 1/3. Okay, so those are all some variations on the power rule. And I guess I did say I would also do one more for you where you had to simplify it first. So if I gave you one like this, let's say I gave you x squared, oh wait. Okay. So I gave you this fraction, x squared plus x over square root of x. And I wanted you to do that derivative. Well, we have no rule for doing a fract like a divide problem. We only have a rule for x raised to a power. That's the only rule we have right now, other than sine and e to the x or whatever. So what we have to do is what? We'll have to do some algebra. We first make this x to the 1/2 down here. And then split it apart or think about flipping that up to the top as x to the negative 1/2, whichever you prefer. I would rather split it apart. I'd rather think of that as x squared over x to the 1/2 plus x over x to the 1/2, like that. Right? Same thing. And now you do what with the powers? No. No, they're already the same. We could add them, but then it just gives us back to here. We don't want to do that. We subtract the power, right? So x squared over x to the 1/2 is what? X to the 1.5, we don't want to use mixed numbers. 3/2, right? This would be x to the 3/2 plus, and then this one, 1 take away half would be 1/2. Now, have I done the derivative yet? This is where people get confused. They did all this work and they think they're done. No, all we did was some algebra. All we did was rewrite this in a new form, an equivalent form. So this is still our f function right here, right? I'm now ready to do the derivative of that. And what would it be? Do the derivative of the first one. Bring the 3/2 down in front. X to the 1/2. Right? So I bring the power down in front and then subtract 1 from the power. So there's my derivative. Now you don't have to go back into square root notation and do a bunch of simplifying of that. Once we get to there, we can pretty much just leave. But we had it. So the end of your homework today, there's some of that kind of stuff. We got to do some algebra first to rewrite it so it looks like power, and then we can do our rule. So one of the reasons you had to learn all that algebra mumbo jumbo and simplifying and practicing, because without it, we couldn't really do our derivative without putting it into that form. All right, so on your homework sheet, okay, has everybody got one of those? Chapter 2, homework sheet. Oh yes, I got to show you that third thing. I'll show you that as soon as I tell you the homework here. Actually, that'll help you get started. Okay, so the chapter 2 homework sheet, the next line down, there's actually 2 lines for your homework, okay? There's the 2.2 homework. There's the 2.2 homework questions. Most of those involve the shortcuts. Right, Sam? It was really Riley, but I didn't call him. Or maybe it was Sam. It was Sam's fault. It was Sam. So 2.2. That's what I mean. Got a good grade on the quiz. Okay.
I have no idea.
I don't know. You know, see, he's already coasting. He's coasting already. I don't actually. But 2.2, those are mostly shortcut. Okay, and then it says do the derivative of 1 over x and square root of x by the definition, the long one. So square root of x, 1 over x. 1 over x obviously is going to involve getting a common denominator. Square root of x is going to involve the third algebra technique And let me show you what that will look like. Okay? So the third algebra technique is called multiplying by the conjugate. Now the conjugate is this. If you have A plus B, you multiply it by A minus B. Now that's not opposite. Some people think that's opposite. That's not opposite. It's a conjugate. You change a plus to a minus in there. When you multiply that out, FOIL that out, something nice happens. What do you get? The outers and inners disappear. Now that turns out to be handy because what you get are two things that are squared. It comes in real handy when we're working with square roots. You may remember last year, or in Honors Algebra 2 probably mostly, that if I had 4 over 3 plus square root of x, and I needed to get the radical out of the denominator. Now that's not the same thing we'll be using it for. We won't be using it for getting it out of the denominator. I'll help you set up the one we do today. But the way we would get that out of the denominator is we multiply the top and bottom by the conjugate, which is what? 3 minus the square root of x. And what that did for us is on top we would get 12 minus 4 square root of x. We didn't care if we had a square root up there. But here on the bottom, when we FOILed it, we'd get what? 9 minus x. And the square root disappeared because the outers and inners would go away. 3 times 3 is 9. Square root of x times square root of x is x. Okay? So you need to be able to do these 3 algebra techniques. Factor and cancel, bow tie, get a common denominator, multiply by a conjugate. All right, where's that going to come into play? Well, one of your homework assignments is to do the long method for that derivative right there. Okay? That's one of them right here. Right here. That's on the assignment sheet. That's the second line. So it says do 2.2, and then it says do the derivative of 1 over x and square root of x by the definition. Okay? So you've got to do this by the definition. So that means you've got to set up this. So in your first step, you're going to do f of x plus h. Well, what's f of x plus h going to look like with that? You're going to have square root of x plus h. And then minus f of x. You're going to have square root of x. Okay? All over h. Now what in the world do you do with it? You multiply by the conjugate. On the top, we've got square root minus the square root. So we want to multiply the top and bottom by this plus that. Multiply that on the top, multiply that on the bottom. Nice things should happen. Okay? There you go. Should. All right, get the rest of the time to work, and I will help you that off. The well, yeah, anytime you multiply like a 3 over 3 or whatever, that's a well-chosen one. Anytime you multiply by 1, you don't affect the thing. So that is definitely a well-chosen one. There are other times where you use the term well-chosen one, but this would be one of them. Well, I didn't go around to this. I'm probably not ever going to check to see if you have to. If that's your question, yes, I'm not. But there will certainly be things you better be able to do out of it. So that's totally up to you. Yes.
Can we come up and see what that is?
Yeah. One at a time. Maybe I'll turn this off.